Okay, today we have to discuss center of mass. So yesterday I was about to explain that center of mass, and I showed a figure. Let me see where is the figure. And I showed that example with the mobile. See, again, I think if you are able to see this mobile. And here I am supporting this mobile with all my 5 fingers. Now it is balanced. Suppose I am exerting all these forces at one end, what will happen? It will fall. One end only, that will fall. And so the weight of the mobile is balanced by my fingers. Instead of that, if I exert force at the center, or here this is a rectangular shaped mobile, so its center of mass will be at the center. That means point of intersection of these diagonals. Square also it will be like that. And for a triangle it will be point of intersection of its medians, like that. So here in this case, now all the forces were exerted at one particular point, and you children also have that habit of balancing a book with a pencil or your finger like this. I have seen children doing and rotating that also, isn't it? You are knowing that. Okay. So like that, you can balance it at a particular point, and that point is considered as center of mass. I am not balance. Okay, so you may be able to. So balancing a book with a pencil or your fingertip, etc. You are knowing about that, and that is actually the center of mass. Its weight is actually center of gravity also same. Center of mass and center of gravity are same when bodies are having uniform distribution of mass and having a particular geometrical shape. For example, a book rectangular in shape. So point of intersection of that diagonals will be center of mass as well as the center of gravity. Center of gravity we can discuss later. Okay. So like that, if you take your book, it is in rectangular shape. So where will be the center of mass lie? At the point of intersection of diagonals. Waiting. Abarna with the point. So, and one more thing. So, now we have seen the center of mass. In some bodies, center of mass will be there. But in some other cases, even there is no mass at all. For example, if you consider a ring, you may be aware of the ring which you are playing, PT period and all ring. So, in the case of a ring, where will the center of mass lie? It also is at the center of the ring because it is having a geometrical shape. So center of that ring is in circular shape. So center of the ring will be center of mass. Center of mass lie at the center of the ring. Is there any mass at the center of the ring? Is there any mass? No mass.
No, ma'am.
Yes, no mass is there. So even though there is no mass, we consider a point at the center of the ring. That is the center of mass. So, center of mass is sometimes there will be mass, sometimes there may not be any mass. So, center of mass of a body or a system of body is defined as the point at which the entire mass of the body is supposed to be concentrated. So the whole mass of the body is supposed to be concentrated at that point. So that is the definition for center of mass. Center of mass of a body or a system of bodies is defined as the point at which the entire mass of the body or the system of bodies is supposed to be concentrated. And if all the external forces acting on the body or the system of bodies were to be applied at the center of mass, so in this particular case, Adil coming late every day. 29. So here, in the case of mobile itself, I will show you. Yeah. See, the whole mass of the body is concentrated at center, geometrical center, and here I can move the mobile in any way. See, even though I have applied the force at the center, I can move the mobile in any direction. And when it was distributed, when the masses were distributed, and I applied my 5 fingers in different points, and I am able to move the body in the same way as I have done when all the mass were concentrated at the center. So that is not affected. That means motion of the body is not affected even if we apply the force at the center of mass. So the motion of the body is not affected when we apply the force at the center of mass. So instead of applying all the particles, if the whole force is applied is at the center of mass, its motion is not affected. Such a point is center of mass. So that is the definition for center of mass. It is not at all necessary that the total mass of the system be actually present at the center of mass. That is what I told. In the case of a ring, there is no mass, but it is we think we only think that, theoretically think that there is a point at the center, and then their mass of the body is supposed to be concentrated at the center. It is only theoretical. Practically, certain cases there is mass, at certain cases there is no mass at all. Okay. In the case of disk, we know there is mass, disk shape. But in the case of a ring, there is no mass. So it is only a theoretical point, center of mass. And it is not at all necessary that the total mass of the system be actually present at the center of mass. In fact, in certain cases, there may not be any mass present at the center of mass. So that is the idea of center of mass. So what is center of mass? Center of mass is the point where the entire mass of the body is supposed to be concentrated. The motion of the body is not affected if the whole force were applied at the center of mass. It will be remain same. And sometimes there may be mass, sometimes there may not be any mass at the center of mass. Depends on the bodies. Then next is position vector of center. Now we are about to study the motion of center of mass. So we have studied the laws of motions and all. First chapter we studied motion in a straight line, motion in a plane. We have studied motion of a body. And here whole mass is concentrated at the center of mass. So we have to study the motion of center of mass. So for that, the simplest system is what we are considering to study the motion of center of mass. First, we have to discuss position vector of center of mass. Position vector we have studied, but this is position vector of center of mass of two particle system. So system means, I told you, system means a collection of large number of particles. That is system. When a rock is taken, we made up of large number of particles. When we take water in a glass, it consists of large number of particles. So that is a system. And here, position vector of center of mass of two particle system. So we know large number of particles are there when we take a rigid body. And the simplest one is two particle system. So you have to consider a system which is having only two particles, and its masses are m1 and m2, and their distances from the origin. This is origin, this is x-axis, and this is y-axis, and from origin, that distance, that is the position vector, that is x1, and for the mass m2, they are not taken as equal mass. One mass is smaller, other mass is greater, different mass they are having. So how many particles are there in the system? How many particles are there in the system? Two particles.
Two.
Yes. Which are their masses?
M1 and
M2. What are their distances from the origin?
X1 and X2.
X1 and X2, correct. Pranav is waiting. Pranav every day coming. See what is the time? 11:16. Now only he is coming. So here, see, we know in a two-particle system, somewhere the center of mass will be there. If the particles are having equal mass, then you can take at the center. That means this is x1, this is x1, and this distance is x2. So at the middle point, you will get the position of center of mass. So that distance will be position vector of center of mass. Middle point. That happens only when the two masses are equal. When the two masses are equal, then, and you see, center of mass will be at the center only when the two particles are having equal mass. That we can discuss as special case. So now what we are going to find? Position vector. Where should the center of mass lie? That is what we have to find out. In such a system, two particles are there, their distances are x1 and x2 from the origin. In that case, where will the center of mass lie? That is the question. And for finding that, there is a formula. And see, mass of the body into its distance from the origin. M1 x1 plus mass of the body into that distance x2. So we get m1 x1 plus m2 x2 whole divided by total mass m1 plus m2. This is the equation used to find position vector of center of mass of two particle system. That means product of mass and its distance plus product of the other mass and its distance whole divided by total mass of the system. m1 x1 plus m2 x2 by m1 plus m2. This is the equation to find position vector of center of mass. What is x? X is the position vector of center of mass. Okay. And if the system is having large number of n particles, what will be the formula if the system is having n particles? Can anyone tell? What will be the formula if the system is having n particles? Can anyone tell? This is for two particles. If the system is a big rigid body, which is having a large number of particles, and their distances are from x1, x2, x3, etc., xn. Masses are m1, m2, m3, etc., mn. In such case, where will the center of mass lie? What's the formula? Can you tell, children? Anyone can tell? No? Two particle you got, n particle. What will be the equation? Who will tell? Jnanaprakasham only is there. Jnanaprakasham, what will be for n particles?
N into M1 x1 to x2.
M1, see two particles are there. This is the formula. M1, first particle into its distance. Second particle into its distance by total mass. So n particles are there. What will be the extent? How will you extend this? M1 x1 plus M2 x2 plus, well, what is the third particle?
M3.
M3
x3
plus etc. etc.
M1 mn xn.
xn whole divided by what we should write?
Whole divided.
Whole divided by
total mass of the body.
Yes, m1 plus m2 plus m3 plus
m1 plus m2 plus m3
plus mn n particle. That will be the total mass. So that is a general case. for n particles. This is for two particle system. So this derivation is a 2-mark question, derived expression for position vector of center of mass. Such a question come, what will you do? First you have to draw diagram and you have to show the two particles in the system, and it is kept along the x-axis, and their distances you have to mark x1 and x2, and you just mark a point somewhere in between, and that distance is marked as x. We don't know whether it is center or not. If the mass is heavier here, near to it the center of mass will lie, near to it, heavier here, then only it will be balanced. You may be knowing if mass is more at some part, we have to keep our finger here to balance that, like that. Center of mass will be near to the heavier mass. Understand? So like that, x is the position vector of center of mass. That means from the origin, it is at a distance x. Center of mass is at a distance x from origin. So this is the equation. Remember this equation. Special case. See, if two particles are having equal mass, what change will come in the formula? M1 equal to M2 equal to M. We can take M1 equal to M2 equal to M. Same mass. So Mx1 plus Mx2 by 2M. M1 plus M2 becomes 2M. So M and M get cancelled and we get X1 plus X2 by 2. So its center of mass lie at the center. So when will the center of mass lie at the center in the case of a two-particle system? When the masses of the particles
are equal.
Yes, very good. For two particles of equal mass, center of mass lie midway. If the system is having n particles with masses m1, m2, etc., mn at distances x1, x2, xn from the origin, then x equal to, what is x? Position vector of center of mass. X equal to m1 x1 plus m2 x2 plus etc. plus mn xn whole divided by m1 plus m2 plus etc. plus mn. And using sigma we can express this. So we will not tell like this m1 x1 m2 x2. No. We just can express with sigma. Sigma I equal to 1 to n. I is varying from 1 to n. And what all terms are there? M1, x1. 1, see, I is varying from 1 to n. So in place of 1, 2, 3, there you have to keep I. X1 also is varying. X1, x2, x3, etc. So there also you have to put I. So mi xi. Then you have to write here sigma. I is varying from 1 to n. Sigma I is varying from 1 to I is equal to 1 to n you have to give. And then add. That sigma means sum. Sigma I equal to 1 to n. Mi xi. Similarly, the denominator what is there? M1 plus M2 plus etc. plus Mn. So I here Mi you can give, and sigma I is varying from 1 to n. That also you have to give here. Sigma I equal to 1 to n. Sigma means sum. M1 plus M2 plus etc. Mn. Instead of writing that, what we can write? Sigma I equal to 1 to n Mi. So this is the formula using sigma, position vector center of mass of n particle system. Two particle we know, n particle, this is the formula. Then we are studying motion of center of mass. For that, first we have taken position vector of center of mass. Then next, after position vector, what is it? Velocity vector, dr by dt. R is, this is position vector R. So as we have done in the last chapters, laws of motion, here we give R instead of X, we give R, position vector. This 30 now. So position vector center of mass R is position vector. We know, we have studied motion in a plane. We have represented position vector as R. Here we represent it capital R because it is center of mass. Capital R is used to represent position vector. and it is a vector quantity. So we write vector r and suffix we have to write cm. What is cm? Center of mass. Center of mass. Okay. Position vector of center of mass in the place of x. What we have written? R, capital R, is equal to sigma I equal to 1 to n mi. Here x, in the place of x you give r, because it is the what we have studied in other chapters. R is used to represent the position vector. That's why we have replaced x with r. Mi ri by sigma I equal to 1 to n mi. So this is equal to sigma I equal to 1 to n mi ri by total mass, capital M. We can write total mass. Then you have to cross multiply m into r, center of mass, equal to sigma I equal to 1 to n. Cross multiply. The relations and all you have to write and study. Okay. Now we got position vector. Then we are going to cross multiply. You see, we are going to find the expression for force. So mass into position vector. What is mass into position vector? That is sigma equal to 1 to n mi ri. Expanding m1 r1 vector plus m2 r2 vector plus etc. mn r. We got. Then differentiating with respect to time. Okay, m is constant. No need to differentiate. Only this one is varying, position vector. So dr by dt. dr cm. Cm means center of mass. Differentiating, we are going to find the expression for force. So when we study motion of a body, first position vector, then velocity vector. Where is velocity vector? Velocity vector is not there. That we see later. Okay. So m into rcm. rcm means position vector of center of mass, equal to sigma I equal to 1 to n mi ri vector. Expanding why we expand? Because we have to differentiate that. m1 r1 vector plus m2 vector r2 plus etc. mn vector rn. Differentiating with respect to time. Here left side differentiate m into dr by dt equal to m1 into dr1 by dt plus m2 into dr2 by dt plus etc. mn into drn by dt. What is dr by dt? Velocity. So this is position vector center of mass. So its velocity we are getting here. Total mass into velocity vector of center of mass equal to m1 m into velocity vector of center of mass equal to m1 v1 dr1 by dt v1. First particles velocity. System of particle no. So all the particles we are considering. Second particle m2 v2 plus etc. mn vn. So n particles are there. So what is mass into velocity? Mass into velocity is actually momentum. So total momentum is sum of the momentum of individual particles. So next we are differentiating again. Again differentiating, what we get? What is dv by dt? dr by dt is v. What is dv by dt, children? Aparna, what is dv by dt?
Acceleration.
Very good. Acceleration. So dv by dt is acceleration. So m into dA, capital A is used. Be careful. As it is center of mass, we are using capital letters. So here a capital letter A is used to represent acceleration. So vector A, cm, center of mass, is equal to m1 into dv1 by dt. That means acceleration of the particle of mass m1. m1, small letter a1. Individual particles we give small letter. Center of mass only we give capital letter. So m1 a1 plus m2 a2 plus etc. plus mn an. What is an? It is the acceleration of nth particle of mass mn. Then capital M into dv by dt is acceleration we got. So that is what is MA, children? What is MA? Mass into acceleration.
Velocity.
Mass into acceleration is force.
Velocity.
Mass into acceleration is
Force.
force. Yes, force. According to
Force.
Newton's second law, mass into acceleration is force. So that we can first particle, the force acting on first particle F1, vector F1, plus force acting on second particle vector F2, plus etc. Force acting on nth particle vector Fn. That means total force acting on all the particles of the system F1 plus F2 plus etc. plus Fn. So we can write capital M into acceleration. Yes.
Teacher, ഇതിലെ force എന്ന് ഉദ്ദേശിക്കുന്നത് internal ആണോ external ആണോ?
External ആണ്. Internal force I told you now, it will not make any motion. Only external force can change in the position of the body. Okay. So internal, they will cancel each other. But here it is the external force, total force acting on the body. F external is equal to vector F1 plus vector F2 plus etc. vector F1. So mass into acceleration of center of mass, we know this mass into acceleration is force. But instead of acting the forces on all the particles, the mass is exerted on the center of mass. That will produce the same effect in the body. We can, if suppose we are exerting the force to stop the body, and we are acting that force on the center of mass, that can be done. Instead of acting the forces on all the particles, we can exert that force at the center of mass to move the body. Understand? So instead of applying all the forces on all the particles of the body, we are exerting the same force at the center of mass and producing the same kind of motion in the body. That is the idea of center of mass. No need to study the motion of individual particles. Just we apply the force at the center of mass and we study its motion. So mass into the acceleration of center of mass is the total external force acting on the system. F external represents sum of all the external forces acting on the system of particles. Equation 4 states that center of mass of a system of particle moves as if all the mass of the system were concentrated at the center of mass. And here there is an example to explain motion of center of mass. Motion of center of mass. Here, explosion is taking place. Here it is a firecracker now. Firecracker. You can consider that example. Okay, anyone write? No, 29. So a firecracker. So after lighting the cracker, so you are throwing. ദീപാവലിക്ക് പടക്കം പൊട്ടിച്ചോ? ആരെങ്കിലും ഇല്ലല്ലേ?
Yes, teacher.
പൊട്ടിച്ചാ? ശരി. അതിനൊന്നൊരു കുറവില്ലല്ലേ കൊറോണ ആയാലും? വേണം. കൊറോണ എന്ന് പറഞ്ഞു ഇങ്ങനെ വിഷമിച്ചിരുന്നിട്ട് കാര്യം ഉണ്ടാവും. അത്യാവശ്യം കൂട്ടുകാരൊക്കെ തൊട്ടടുത്തുള്ളവരൊക്കെ ആയിട്ടൊക്കെ കളിക്കൊക്കെ ചെയ്യാം. ഒക്കെ വേണ്ടേ? സന്തോഷമൊക്കെ വേണ്ടേ? അടുത്താരാ കൂട്ടുകാരൊക്കെ ഉണ്ടോ? അവിടെ പോയി അല്ലേ? അതുപോലെ തൊട്ടടുത്ത് വല്ല കുട്ടികളൊക്കെ ഉണ്ടെങ്കിൽ അകലേക്കൊന്നും പോയി കൊറോണ ഒന്നും പറ്റിക്കരുത്. അടുത്തൊക്കെ പോയി അടുത്തുള്ളവരൊക്കെ ആണെങ്കിൽ കളിക്കാം. അവരൊന്നും പുറത്ത് പോകാത്തവരും ഒക്കെ ആണെങ്കിൽ കുഴപ്പമില്ല, ശ്രദ്ധിക്കണം കേട്ടോ. അപ്പോ നമുക്ക് അപ്പൊ ക്രാക്കറിന്റെ കാര്യമാണ് ഞാൻ പറഞ്ഞത്. അപ്പൊ ആഫ്റ്റർ ലൈറ്റിംഗ് ദ ക്രാക്കർ സപ്പോസ് വി ത്രോ വി നോ ഇറ്റ് മൂവ് ലൈക്ക് ദിസ് പാത്ത് അല്ലേ? പാരബോളിക് പാത്തിലല്ലേ നമ്മളിങ്ങനെ എറിഞ്ഞു കഴിഞ്ഞാൽ പോവാ, കടക്കം കത്തിച്ചെറിഞ്ഞു കഴിഞ്ഞാല് ഇങ്ങനെയല്ലേ? പാരബോളിക് പാത്തിലല്ലേ പോവാ നമ്മൾ എറിഞ്ഞാൽ? നേരെ എറിഞ്ഞാൽ നേരെ പോകും. അതല്ല നമ്മൾ സാധാരണ ഇങ്ങനെ വലിച്ചെറിയ ഇങ്ങനെ എറിയുകയാണെങ്കിൽ ആംഗിൾ ഓഫ് പ്രൊട്ടക്ഷൻ ഇങ്ങനെ കൊടുക്കുകയാണെങ്കിൽ ഇങ്ങനെ പോയിട്ട് എവിടെയെങ്കിലും എത്തുന്നത് അല്ലേ? എക്സ്പ്ലോഷൻ നടക്കും. ആൻഡ് എക്സ്പ്ലോഷൻ ഏത് ഫോഴ്സ് കൊണ്ടാണെന്ന് പറയാൻ പറ്റുമോ? ഈസ് ഇറ്റ് ഡ്യൂ ടു ഇന്റേണൽ ഓർ എക്സ്റ്റേണൽ ഫോഴ്സ്? എക്സ്പ്ലോഷൻ വെരി ഗുഡ്, ഇന്റേണൽ ഫോഴ്സ്. എക്സ്പ്ലോഷൻ നടക്കുന്ന ഇന്റേണൽ ഫോഴ്സ് കൊണ്ടാണ്. അപ്പോൾ ഇന്റേണൽ ഫോഴ്സസ് കനോട്ട് മേക്ക് എനി change in the motion of center of mass. Only external forces can change the motion of center of mass. ഇപ്പോൾ ഇവിടെ എക്സ്റ്റേണൽ ഫോഴ്സ് ഏതാ? ഒരു ക്രാക്കർ നമ്മൾ വലിച്ചെറിഞ്ഞു കഴിഞ്ഞാൽ അതുപോലെ ആക്ട് ചെയ്യുന്ന എക്സ്റ്റേണൽ ഫോഴ്സ് എന്താണ്? Tell me. It is the external force acting. അതെന്തുകൊണ്ടാണ് ആ പാരബോളിക് പാത്തിൽ മൂവ് ചെയ്യുന്നത്? ഏതാണ് അവിടുത്തെ ഫോഴ്സ് ആക്ട് ചെയ്യുന്നത്? ഒക്കെ ടീച്ചർ പഠിപ്പിച്ചു കഴിഞ്ഞാണ് കേട്ടാ. ഒരു ബോഡി നമ്മൾ ഇങ്ങനെ വലിച്ചു കഴിഞ്ഞു കഴിഞ്ഞാൽ അത് ഇങ്ങനെ ഒരു പാരബോളിക് പാത്തിൽ മൂവ് ചെയ്യാനുള്ള കാരണം എന്താണ്? ഏതൊരു ഫോഴ്സ് കൊണ്ടാണ് അതങ്ങനെ മൂവ് ചെയ്യുന്നത്? ഏത് ഫോഴ്സ് ആണ്? പ്ലീസ് ടെൽ. Gravitational force. Correct answer. Give a clap to him. Nobody is answering. ജ്ഞാനപ്രകാശ് മാത്രമേ പറയുന്നുള്ളൂ അല്ലേ? ജ്ഞാനപ്രകാശ് അല്ലേ പറഞ്ഞേ? വെരി ഗുഡ്. വെരി ഗുഡ്. കണ്ടാ ശ്രദ്ധിച്ചിരിക്കണം ക്ലാസ്സിൽ. എല്ലാരും ഒന്നില്ലെങ്കിൽ അത് കിട്ടുന്ന ആൻസർ പറയാ. ആരും ഒന്നും പറയില്ല. ജ്ഞാനപ്രകാശും പറയില്ല, ഇടയ്ക്ക് ദീപാംശ പറയുന്നു. ആരും ഒന്നും പറയില്ല. പറഞ്ഞാലല്ലേ ക്ലാസ് ആക്റ്റീവ് ആവുള്ളൂ. ടീച്ചർക്കും അതൊരു ഇതല്ലേ, എടുക്കാനായിട്ട് സന്തോഷമല്ലേ നിങ്ങളെ പറയുന്നത്. അപ്പൊ ഓൺലി എക്സ്റ്റേണൽ ഫോഴ്സ് ആക്ടിങ് ഈസ് ഗ്രാവിറ്റേഷണൽ ഫോഴ്സ് ദയർ. അപ്പൊ ഓൺലി ദ മോഷൻ ഓഫ് ദി സെന്റർ ഓഫ് മാസ് ഈസ് അഫക്റ്റഡ് ബൈ ഗ്രാവിറ്റേഷണൽ ഫോഴ്സ്. ഇന്റേണൽ ഫോഴ്സ് കൊണ്ട് സെന്റർ ഓഫ് മാസിന്റെ മോഷൻ അഫക്ട് ചെയ്യാൻ പറ്റില്ല. ഇന്റേണൽ ഫോഴ്സ് കൊണ്ടാണ് അത് എക്സ്പ്ലോഷൻ നടന്നത്. അപ്പൊ സെന്റർ ഓഫ് മാസ് ഇനി എങ്ങനെ പോകും? ബേസ്റ്റ് ചെയ്ത് കഴിഞ്ഞാൽ പിന്നെ നമുക്കറിയാം അവിടെ ഒരു പാർട്ടിക്കിളും ഉണ്ടാവില്ല, തെറിച്ചു പോയി. എല്ലാ പാർട്ടിക്കിൾസ് ഒക്കെ തെറിച്ചു പോയിട്ടുണ്ടാവും. അപ്പൊ സെന്റർ ഓഫ് മാസ് എന്ന് പറഞ്ഞ ഒരു പാർട്ടിക്കിൾ ഉണ്ടല്ലോ, ഒരു ബോഡി എടുത്തു കഴിഞ്ഞാൽ നമുക്കറിയാം സെന്റർ ഓഫ് മാസ് ഉണ്ട് അവിടെ. ആ സെന്റർ ഓഫ് മാസ് എന്ത് സംഭവിക്കും ആഫ്റ്റർ ദ എക്സ്പ്ലോഷൻ? വിച്ച് ഡയറക്ഷൻ സെന്റർ ഓഫ് മാസ് വിൽ മൂവ്? The motion of center of mass is not affected by the internal forces. The motion of center of mass is not affected by internal forces. Actually, before explosion, it was moving along a parabolic path. So, there was gravitational force. Before explosion, there is gravitational force. After explosion, also there is gravitational force. Only the gravitational force can affect. Here, only gravitational force is there. So, only that gravitational force can affect the motion of center of mass. So, in its direction, the center of mass will move. What is your idea? I am asking your idea. So, I told you the motion of center of mass is not affected by internal forces. It is affected only by the external forces acting on the system. So, before explosion, it was moving along a parabolic path. So, after explosion, what do you think? In which direction it will move? Center of mass. What will be the direction or motion of center of mass? What is your idea?
Parabolic path.
Very good. It will continue to move along the parabolic path because the motion of center of mass is not affected by internal forces. It is affected only by the external force. Which is the external force here? External force is gravity, gravitational force. Before gravity, it was moving along a parabolic path. So, it will continue its motion along the same parabolic path which it was moving before explosion. So, that's the motion of center of mass in the study. Motion of center of mass. How will you explain motion of center of mass? നമ്മൾ ഇത്രയും നേരം പറഞ്ഞത് തന്നെയാണ്. അതായത് motion of center of mass is not affected by the internal forces. Only external force will affect the motion of center of mass. അതാണ് നമ്മൾ പഠിച്ചത്. അപ്പോൾ അതാണ് ഇവിടെ എക്സ്പ്ലെയിൻ ചെയ്തിരിക്കുന്നത്. മോഷൻ ഓഫ് സെന്റർ ഓഫ് മാസ് എങ്ങനെയായിരിക്കും ആഫ്റ്റർ എക്സ്പ്ലോഷൻ, അതാണ് ഇപ്പോൾ നമ്മൾ ഇവിടെ എക്സ്പ്ലെയിൻ ചെയ്തിരിക്കുന്നത്. ഓക്കെ. പ്രൊജക്ടൈൽ ഫോളോയിങ് ദ യൂഷ്വൽ പാരബോളിക് ട്രജക്ടറി എക്സ്പ്ലോർസ് ഇൻടു, ഇവിടെ പ്രൊജക്ടൈൽ എന്ന് പറഞ്ഞത് ഫയർ ക്രാക്കറാണ് ഉദ്ദേശിച്ചത്. Explodes into fragments midway in air. The forces leading to the explosion are internal forces. They contribute nothing to the motion of center of mass. The total external forces, namely the force of gravity acting on the body, is the same before and after the explosion. Center of mass under the influence of external force continues therefore along the same parabolic path as it would have followed if there were no explosion. So, center of mass will continue to move along the same parabolic path which it was moving before explosion. So, So that is about the motion of center of mass. Example, one example for you. Next, so now we have studied the force, about force acting on center of mass. And next, in momentum also we have to study. When you study motion of center of mass, position vector, velocity vector, acceleration vector, force vector, then linear momentum vector, all such things we have to apply to center of mass also. So that is done here. Next, linear momentum of system of particles. So you are considering a system, it is having n particles, and for the system of n particle, linear momentum of the system is defined to be vector sum of momentum of all the individual particles. So this is the total momentum of the system, that is equal to sum of momentum of individual particles of the system. So here onwards, when we consider the rigid body, you cannot just write P equal to mv. We have to consider each and every particles of the system, and you have to substitute that. So P equal to m1 v1 plus m2, because momentum is mass into velocity, m2 into etc. 5 minutes more. M and Vn. So total momentum of the system of particle is equal to sum of momentum of individual particles of the system. Then we substitute momentum is mass into velocity. First particle, second particle, what is the product of mass and velocity? m2 vector v2 plus etc. mn vector vn. From equation 3 we have taken P equal to mv, velocity of center of mass. M into velocity of center of mass is momentum. Here this is the momentum of center of mass. Center of mass in the momentum. This is particles in the momentum. Substituting 3 in 5. So that means here this will be total mass into velocity of center of mass. So instead of finding the total momentum of all the particles in the system, we just define the momentum of center of mass. Both are equivalent. So total mass is exerted at that point. We are considering the total mass of the body is concentrated at the center of mass. So total mass into velocity of center of mass will be equal to what? The total momentum acting on all the particles of the system. We have to find the sum of all the momentum of individual particles. So that becomes a difficult task. So what we do, we find the total mass and multiply it with velocity of center of mass. That will be equivalent to this. The total momentum of the system of particle is equal to, this is how you read this, the total momentum of system of particle is equal to the product of total mass of the system of particle and velocity of center of mass. For a system, what is the total momentum of the system? Actually, we have to find the momentum of all the particles of the system and we have to add it. Instead of that, what we do, we find the product of total mass of the system and multiply it with the velocity of center of mass. That will give the same effect. Okay. The total momentum of the system of particle is equal to the product of total mass of the system and the velocity of its center of mass. Okay. Then Newton's second law extended to a system of particles. We know momentum P. What is Newton's second law? Rate of change of momentum is force. That is Newton's second law. Rate of change of momentum, dP by dt. Actually, that is related, but in this case we have to apply that. What is Newton's second law? Rate of change of momentum, dP by dt. That is rate of change of momentum. P is momentum. What is the rate of change of momentum? By time. That is time rate of change of momentum. Rate of change of momentum, dP by dt. Then rate of change of momentum, mathematically dP by dt equal to m into, here also we have to differentiate with respect to time. So dV by dt. dP by dt equal to m into total mass into, this is about center of mass or momentum of a system of particles. Okay. So m into dV by dt. What is dV by dt? Acceleration vector. dp by dt equal to m into acceleration vector, acceleration center of mass. dp by dt equal to mass into acceleration is force, F external. Mass into acceleration is F external. Suppose that the sum of the external forces acting on the system of particle is 0. This is the equation for second law, Newton's second law. When it is applied to the system of particle, this is the equation. Total external force acting on the system is equal to rate of change of momentum of center of mass. This is the momentum of center of mass. So this Newton's second law is applied to system of particle. This is the formula. Then special case we are discussing. Suppose that the sum of the external forces acting on the system of particle is 0. Suppose there is no external force acting on the system. Then we have to take this as 0. So dp by dt equal to 0. And we have studied according to the equations of differentiation, derivative of constant is 0. That we have studied in the formula.